Swayam Prabha. Digital India. Educated India.
That's the other way. Is it other way? It's the other way, right? Good. So, okay, let's repeat this. So, you have operation which is defined for account. You can use it for savings, correct. Similarly, if you have operation for array of account, you should be able to use it for array of savings. That is basically allowed, that is a subsumption rule. Okay. If term has a type A and A is a subtype of B, then the term also has a type B. Got it? So, that term is here is array here. Okay. Now, so here remember that this particular most of the languages do support, but it is not always true, okay, and there is always a restriction that exists, and subsumption rule is very important whenever we talk about this particular kind of subtype polymorphism, because how the see this is the way that you need to look at that, how these languages actually define the types, define the type expression and the type system. That is very important here to remember. How the types are defined, types can be evolved, types can be in fact combined, types can be the overall type system can be defined. Okay. That is very important to understand that from this particular kind of course, that when we talk about the design concepts of object oriented, this is basically something that you need to understand here, that the types actually are introduced. Now, there is some concepts are getting implemented like a polymorphism, but there is a, you need to think about the composition, you need to think about this particular different ways of combining this type. Okay, you are defining the array of type. Now, let us look at in the on the similar lines, let us consider now, if I define list of account and list of savings, can I replace wherever the list of account is a parameter, can I pass list of savings as a parameter? Getting it? What we said, whenever there is a operation where there is a account as a parameter, I can pass savings as a parameter, correct? Can I, correct or not, right? Can I pass, because savings is a subtype of account. So, can I pass, I can do the same thing for array, but if there is an operation which is defined over list of account, can I pass list of savings as a parameter? So, as I mentioned here, there will be certain constraints, and that is where Java will not allow that. Java will not allow that, and many languages do not allow that. So, let us now look at it more from the perspective of formal way of defining this subtyping and the subsumption. We will talk, we will check the example, I will give you that I do not know whether it is exercise, but we will talk about that, take that example of that. So, let us revisit this particular now subtypes and the subsumption in a more formal way. So, relationship between primitive types here is that byte is a subtype of short, correct. Short is a subtype of int. So, whatever is applicable for int obviously will be applicable for short, correct. So, like that. For the reference type T1 extends T2, that means T1 is a subtype of T2, correct. We know all of the now, just now we talked about the savings and account. If T1 implements T2, then also T1 is a subtype of T2, right, no confusion. T1 is a T1 is a subtype of T2, then also implies array of T1 is a subtype of array of T2. So, T1 is a primitive type and T2 is a reference type, then this kind of relationship is not true, and this in case of Java actually we are talking here right now, and you need to say that okay, T2 is always a subtype of object. Okay, T2 of object is always true, but remember that list of object, you cannot replace list of T2, you cannot replace list of object by list of T2, okay, that will not work. Okay, try it out. Okay, in certain cases it will work, but many cases it will not work actually, wherever. Okay, we will see that part later. Okay, now let us look at this subtyping and subsumption example. Are you getting it here up to this point or not? Got it or not? Very simple, it is not difficult, only thing is that we are looking it from the different angle. Okay, you have learned all this thing, programming as a language, programming and language as such, but maybe we are talking about a different angle here. Let us look at the class aircraft here, and this class aircraft actually airplane extends aircraft, jet extends airplane. Okay, let us look at this relationship. Okay, airplane extends aircraft, jet extends airplane. I am slightly different example than your student and all. Helicopter extends aircraft. Okay, in this case what is the subclass relationship? Subclass relationship is jet subtype of airplane, subtype of aircraft. Good, all of you are with me. Helicopter is subtype of aircraft. Good, great. So obviously here if you look at the example that I define this aircraft, I define the aircraft, remember that. I define aircraft which is a aircraft which is a basically aircraft array I have defined, and then I am assigning fleet 0 as new airplane, fleet 1 as a new helicopter. So obviously I can do that. Subsumption rule, correct, right. So obviously the term wise I can do that actually, and also subtyping rule is also there, right. I can assign to that particular variable of aircraft, right. Any question? No. So now the same thing, obviously when I say fleet I take off, obviously jet will take off, or airplane will take off, or maybe helicopter will take off. You have to use virtual in case of C++, but you do not have to use virtual here. Okay. So this is what will happen, right. This is a basically a typical example that okay, how basically I can also do, in fact this is a very interesting part here, you can look at that. Wherever basically aircraft I am saying here, obviously this aircraft fly aircraft I can say, and then it will in fact fly airplane or jet or aircraft. This is a normal, you might have already studied that and you know about, correct. Very simple example, but just I use the different classes here, correct. Okay, now comes the trick here, that this particular subsumption rule is not applicable for generics. So for example, there is a reason for that. So we have a, let us say, fruit as a class, apple as a subtype, Fuji apple as another subtype. I should have taken mango and Alfonso, but that is fine actually. Strawberry as a one of the thing. Then here what is happening here, why following is invalid. When we say list of apple, okay, we are talking about the list instantiated with apples, and when I say list fruits is equal to apple, there is a challenge here basically, because what happens is that in this is invalid, because what will happen is that then that means there is also a possibility that this basically it can be confused with strawberry, okay. Also let us take this particular example and then you will understand. So for example, actually speaking, this is a runtime error by the way, and this should have been caught. This does not get caught in Java kind of languages, that is why they are not as strict typing as Ada kind of languages, and you can do these things and get a runtime error. For example, apples, your defined apples actually is array which is of size 1, okay, and then you are assigning it to the fruits, correct. And I can say this is a perfectly valid, because subtyping actually is applicable here, correct. And fruit 0 is equal to new strawberry, I can say that. Now look at this, fruits is actually fruits is apples, and you are saying, so apple is actually a apple, basically now you are storing that. Storage wise it is a problem first of all, okay. There is a storage constraint that will come. In the case of, it will be a runtime error in case of Java, check that. I mean I remember it should be a runtime error, okay, try it out sometime. So this same thing happens here actually, you do not have the way to further distinguish once it becomes a particular kind of container element. So it is restricted at that particular subtyping rule itself, that generic actually will not allow that subtyping that's rule applicable. So here we have seen here that this particular example we have seen here that T1 extends T2 implies T1 is less, T1 is a subtype of T2, T1 implements T2 implies T1 of subtype, T1 is a subtype of T2 implies T1 array is a subtype of T2, but that is not true. That does not indicate that T1 is a subtype of 2 implies generic using T1 is also subtype of the same generic using T2 as a subtype. So should I write it? It will be clear to you. Did you get it what I said? So T1 is a subtype of T2 up to this point is fine. We have already said T1 array is a subtype of T2 array, correct. List of T1 is not a subtype of list of T2. List of T1 is not a subtype of list of T2. So that is a subsumption. So that subsumption rule which says that if a term has a type A and A is a subtype of B, then term also has a type B, okay. That is not applicable in case of generics kind of thing. Polymorphism, whenever we are talking here, we are talking about a list of T1 is not subtype of list of T2. So how these languages in fact define all this type system, and you should be in fact really you should start looking at that this angle whenever we are talking design concepts of O, or how the programming languages evolve, and how elements of programming languages, principles of programming languages, you need to understand this type system and the restrictions, constraints and all this thing, okay. So why this is not allowed? Because this is the example given here, this becomes a runtime error, but this is caught at the statically only, and you can see the error that you get actually, you can check that error, okay, why this is not working at all, right. Okay, so subtyping is actually is a kind of inheritance only, okay, and inheritance in fact evolved out of this subtyping, and obviously, but there is a, whenever we talk about the inheritance, there is a hierarchy. There is a hierarchy. For example, this particular asset management software, you may not be aware of that, but asset management softwares like maybe something which allows you to manage your assets, whether it is any of the security deposits or bank account or gold or whatever it is, they will define that okay, your asset is a bank account is a asset. Savings is a kind of bank account. Obviously, savings is also part of this particular asset, but ultimately this hierarchy you will be able to define. That is a inheritance. Okay, it is just the way the subtyping evolves basically. Okay, nothing. So subtyping is a subtype polymorphism. Inclusion polymorphism allows you to define. In fact, it's a polymorphism because you have the operation which actually operates on, which is a set of operations rather to say, which are applicable for, even if it is a T1 is a subtype of T2, then it is applicable for that particular, those operations are also available to him, correct. So now this is a more, it is a basically extension of subtype, and there are certain rules that gets applied. We will not discuss more in detail about it, but just one example and how it gets implemented, so that we are nearing our end of this particular session. and I will be giving you more exercises. Just to give you the idea about how these things are implemented, actually inheritance is implemented, and you might have this is a C++ example that this particular here you can see that there are, this is basically the way that you need to define that polymorphism is allowed, basically overload, you can overload these things, right. C++ you must be aware. So you can define f as just to give a highlight of how these things implement. So you can say that f variable, there is a basically f points, obviously you are defining this a and b here, a b as the elements of f, but the f actually variable as such, that particular it will have that virtual table defined where the pointers to that functions will exist. Okay, it is a code pointer, okay, and function pointer. Now whenever you inherit, what happens in the case of inheritance? So here, so sorry, so whenever you are inheriting, for example here class bar inherits foo, obviously this ABC is in fact inherited, but now this m is defined here, we are overriding it. So this particular b will point to the virtual table, again there will be a KLMN, and then after that its own SNT, m is getting overridden here, and obviously that whenever the position of m, if you look at, it is the same here, and this here also it is a 3. Okay, so whenever m is called, okay, whenever m function is called, whether it is called for we can say a foo, a variable is b is assigned to something else, okay, which is of type foo, then still this particular will be, this particular m will be called, that is bars m will be called and not foos, correct, that you must be aware of that, right. So there is a different ways, the different all these languages provide generics and the polymorphism. I have just listed out down few of them. It is available in one of the, actually one particular person from the ADA community has done this comparison to show that okay, where how good is ADA and all, that is what I copied it from. And for example there is a generic in case of ADA, there is a, obviously there is a module concept also, that module concept does not exist in Java, and so you have classes concept only, but you can define actually tagged classes here, tagged types actually. Anyway, you do not have to worry about this too much. This is just to highlight any of this particular, there are multiple parameters on which the generics is compared, and this is the way languages are evolved basically. So generics, whenever the polymorphism is introduced in a language, okay, whether I am providing the, whether I need a explicit instantiation or not, that is the one thing that people check. This language requires a this particular whether the code, whenever it is implemented, generics is implemented, whether it is implemented as a code generics, code sharing or not. For example, every time whenever the generic is implemented, by the way, there is a duplication happens. Okay, what does it mean? That I have a generic which allows me to type parameter as integer, float, etc. Whenever I instantiate it, compiler will actually duplicate the code and create the separate subroutine for integer, separate subroutine for string. You do not know about it, but that is what it is doing, except in Java kind of languages which are interpreted anyway, which are not, so it is a different kind of thing. Okay, so but this is what happens actually. They are duplicated, remember that, ultimately internally by compiler. Okay. Anyway, so this is where we stop on polymorphism, lots of polymorphism, right. Any question? Exhausted? Okay. So let me do one thing before exceptions, let me just give you some examples. So I have talked about these 3-4 examples, few examples already I have mentioned here, maybe I will give more example. For example, C++, some of you are C++ programmer, take this particular, I will give you that, in fact I will send across the PDF to somebody and then you can use all of them. So, these examples are extracted from that, are available in that particular PDF. So, examine C++ language QSORT library, that is there in the C standard library, and implement it for array of student record, where the define the student as the first name, last name, etc. One example 1, this is the exercise 1. Second sixth exercise is, you can choose either of that, I mean you can choose the best ones. And so sixth one is system of so this is a very interesting one. This is actually taken from this ADA language reference manual, and this is a typical kind of thing where you are developing an alert system. Some of them alerts can be a low level alert, some of them can be medium alert, some of them can be high level alert. Now these alerts actually whenever low level alerts are merely you want to log them, somewhere. Then you want to basically medium level alert should cause person to be assigned to deal with the problem, okay. And then high level alerts, alarm bell to ring if the matter is not dealt. So you can use that variant record concept first, but the thing is that apart beyond this, actually if you look at, I need actually a polymorphism to be incorporated, so that it becomes a much easier implementation and much more reusable kind of thing, extendable kind of implementation, okay. So you will find that the concept of polymorphism, inheritance, etc., you will be using in this particular kind of example. Later I have also mentioned that you can implement a variation of this alert where a message is also displayed on the right window of the display channel, but apart from that you want basically this to be in fact to do this as the devices raise alert is now queued to a priority queue. So you have to implement a priority queue which can take which will have this particular alert as a parameter, okay. And then you actually it will change the queue appropriately, and then it will raise that particular alarm or display that particular after doing this action, it will basically display this particular message in that particular window. So this is this try to solve this. Then there is a very interesting simulation that you can do, where you can use object oriented concept. So door control and home security system, where each house has a housing society has a custom main door and a back door, etc. Now you want to have the home security system where you can automatically open and all. There is a reference given there, you can look at that in YouTube. Now this is something that I want to really from the principles of programming languages perspective, I want to take this as an example, as one of the very important one. There is a language called as a Scratch. I do not know whether you have seen that. Scratch environment and the language, actually there is a which is by MIT, okay, and there is a Logo language, you might have heard about it already, okay. Logo you might have heard about it, most of you. Now Scratch actually is also one good language as such. I will say very short verbs and all these thing, actions, you use it to construct different figures and shapes and all these things. So in fact if you look at this kind of language, this kind of functionality, okay, which is typical kind of functionality in the security systems and all this thing, where you have to take certain actions on certain objects. You should be able to in fact define certain kind of this kind of languages, etc., for simulation or animation and all this thing. Look at this language to study that. I am not saying you define that, but study that. It is good to study this kind of languages and know about it. So that is all. I mean other things you can just okay, this is another good example that you can take it. And last one is a simple generic stream parser. Choose either of these 9 examples that I will share, and then we will look at this. Good. You can, I will send across that as a PDF, and you can basically try all these examples as such. But let us now, before we close, let us briefly touch about these exceptions, okay. Okay, last part, exceptions. So you know about exceptions, right? All of you know about exceptions? Yes, okay, good. Very simple, it is not a but the thing is that this particular exceptions, in fact there is a very in fact I am not getting into the too much of theoretical aspects of it, but exceptions actually we will just touch upon how they are implemented. I will just touch upon that, you can look at that more detail. So, to understand how they get implemented etc., we will see that at the end actually, but before that let me just look at normal. What happens is that normally the function is actually there is a normal sequence of equations, sequence of steps basically the program is executing. Okay. So, for example, take an example of your file opening, 99% of it, 99.99% I expect that file to be opened, but there is an exceptional condition that may happen, that there is a exceptional condition that may take place, that either file is locked, opened by somebody, or it is not there, something that happens. So, there is a IO exception that takes place, correct. So, this is an exceptional condition, right, exceptions are exceptions. Now, in the normal course of action, now before we get into this exception part, let us look at the what is the call stack for your whenever your function is called. Okay. I call this function, whenever you call, let us take this particular here, look at this procedure C is calling D and E, correct, and okay. Main program is this, it is calling A is calling B is calling recursively itself, or it is calling C is calling D and E. Is it clear? Main program A, B, recursive calling B, C, there is a C calling D, E. So, A, B, one recursive call, correct, going to C to D. Are you familiar with this stack frame? Okay, right. So, there is a what is this FP? 5? Any louder? 1 minute, 2 of them. You are saying what you are saying? Functional pointer. Functional pointer. You are saying? File pointer. File pointer. So, both of you are wrong. So, do not worry about it. So, are you guys have done compiler course or no? No, okay. But you have studied how basically the calling and all this thing takes place? No, okay, fine. So, let me just explain that whenever you are calling the, briefly we will touch, not get, we do not have time. So, whenever you are calling basically a one procedure is called or one procedure is calling another procedure, obviously that procedure called procedure, when it returns, it has to return to the place where it has basically called that particular, or it has to go to the next instruction from where it is called. Am I clear? So, for example, here I am saying that the A calls main program calls A and A calls B. When B returns, I should go here after B, correct. I should continue here after B, correct. Agreed or no? Okay. Now, that means I need to have that particular return, because I am now setting my program counter PC program counter to this B procedure. Obviously, whenever B returns, I should know where to return, and that is why this call stack is constructed. I can set the number right directly. sorry, thanks. Okay. So, I think I should not let me try to explain this as you are not. So, FP is a frame pointer by the way, and not function pointer or file pointer. So, you have not so SP is a stack pointer, it is a top of the stack, sorry. Actually the reason I am showing you this is that in the normal course of action, FP frame pointer is pointing to the word, or you can say a place from where it can pick up the return address. Whenever B returns, I should go to the basically instruction after B, right. So that frame pointer is basically points to that. Frame pointer is also used to access my local variables and the parameters. Frame pointer is also used to access my, so there is a concept, so if you are not familiar with this, leave this. The reason that I am showing you this, that in the case of exceptions, you are not returning after B, but you are returning to the place where exception is handled, correct. So you need a continuation. So I think I should, maybe I will not get into the deep, I will skip some part, but you need a continuation, and that continuation is basically something which is the way these exceptions are implemented. We will not get into the details of that, I will skip that part at this stage. Once you go through this first, then you can learn about that at a later stage. Okay. So I will be in fact just talk about this exception part. Exceptions, yes, obviously they are like a multi-level return, but they are not exactly multi-level return. You have not heard about the, I do not know how many of you have studied Pascal and all these languages which allows the nesting of subprograms? No, none of you, okay. So leave that. So basically it is a returning at a some other point, okay, than whatever the is the normal return, correct. So now that whenever it is a raise, why it is a raising exceptions means what it is not behaving as expected. Obviously we have seen the example of this file, sorry, we have seen this file opening. 99.9% I can open the file, but 0.0001 or 0.1 point whatever the percentage you have, I am unable to open because it is either locked, not available, or whatever it is. Okay, that is the exception condition. Exceptions are different from interrupts, remember that. Okay, this is exception conditions. Okay, now exceptions is actually in most of the languages it is a basically instance of some predefined or user defined class type. In this case, in the Java case, it is a exception. So test exception, extends exception, I can define my exceptions. File operations define their own exceptions, okay, IO exceptions and all. And in fact, if I have this kind of example, this is a very simple example in Java. Test parse exception is a sorry, forget about test parse exception. We are talking about the main function here, where I am parsing an integer, but I am passing the string to that, and obviously it will raise exception because you cannot parse the string, and so it is raising that number format exception. Okay. So that kind of basically exception is raised. Now if you look at this very interesting part here, that why this continuation is important here is that this actually what we are saying here is that here you can see the stack here. So it is saying that this particular actually raised on the it is raised at the 5th line, go from the bottom of the main subroutine, and then basically that part has called parseInt, which is in Java, etc., etc., and it is ultimately the top of the stack. This was the subroutine which where it has executed on the line 65 something, and there the number format exception was raised. So you are done a multi-level return, correct. You just come out of everything right, and you have actually declared that this particular is a number format exception, I can't do anything. If I handle this exception, what will happen? I will be able to do 1 level, 3 level returns. Still it is a multi-level return for here. If you look at, if I handle it here, this particular exception, then what will happen? I will return from here, multi-level returns I will do, but my continuation will be my exception handler. My continuation will be exception handler. So this exception handler being a continuation, I should be able to provide that or I build that as a part of the compiler, and that actually can be handled in a much better way by the compilers. This is the way the exceptions gets handled by the compiler. Okay, just more about the exception little, just we have 5-10 minutes, so we can just spend there. Exception is a structured exit way, and it's otherwise you will be doing what you will be doing as parseInt will say that I return a passed value, but I also return a maybe a some other value which indicates the error, and it will indicate something else. So this is becomes a very unstructured way of doing it. The purpose of parseInt is to parse integer. If you give the wrong input, it will raise exception, but you will not do it 99.99% you will do it only 0.01%, that may happen, correct. So that is why you should be in fact provide a mechanism to handle this exceptional condition, and that is where it is a structured exit. Now there is obviously it makes a dynamic jump, and in fact earlier days C which does not have exception, there used to be a you can look at that, there used to be a long jump and set jump and long jump kind of functions used to be there in C, which used to allow this particular exception kind of handling mechanism. But that is a very C used to do all the used to allow all the things to be done by yourself. So obviously this is a one way of people, and this was extremely used by the way even by Unix code and all this thing, long jump and set jump and long jump. And so this kind of things where is exceptions is a more formal way of doing it. Okay. Why should we use exception? To obviously your separation of concerns, a typical kind of thing, that why you need to have the modularity, why you need to have the abstractions, it is a separation of concerns basically obviously, and there is a you can have the more flexible control. So this is what I will just put a one slide here, the continuation, which is the abstraction that captures the context which where in which the execution might continue. That is basically the way these exceptions are implemented, and there is a code pointer where to continue, and also the environment pointer that is maintained. Actually environment pointer obviously because you are going to refer to the same variables, right. You do the multi-level return, but you come back to that particular subroutine, obviously you should be able to continue smoothly accessing those variables, parameters, and also you require environment pointer, that is a FP. Again FP will do that, code pointer is where you start, okay, and that is why I was showing that FP and all this stack and all this thing. Okay, I will stop here and I will give you that PDF. I will any one of you can take it if you have this one memory stick, otherwise I will pass it over mail. That is examples actually, other things I will slides I will give it to them, they will upload it actually. Okay, exercises part I will give it to you as a PDF immediately after this, and you have to do exercises. Second half you do, if you do all of them great, if you do at least 50% of them, that you can do it in groups. Some of I do not know how you do the exercises by the way, individually, okay. Either way you decide, I will leave it to you to do that, but learn from that, and definitely learn that Scratch that I mentioned, MIT language, whenever you get time, but first try to do the programming, okay. If any one of you complete that alert system problem, okay, let me see that how you have done it in Java and C++ both. You can send it whenever I come next time, show me that. 22nd I will be there again, so that time you can show me, and till that time you will know more about the compilers and all, hopefully, and so we will talk about that. Learn about that, but definitely it is an interesting thing to learn, and your actually not only programming skills will improve, but your overall basically problem solving skills will improve. Remember that these things actually, let me tell you now the history of all these things actually, generics and all, I have used it in 94, 95, that point when the 83, ADA 83 was introduced. Actually ADA 83 had a generics and all, I started using that ADA in 94 and all. So I used the generics that time, generics came in 76 actually almost, okay, and before that also maybe there, but it was got introduced in a language ML, that is a meta language it is called, and that is basically very popular, and there is a standard ML available actually, you can have a look at that. So those things are many of them, in fact I have a old paper of somebody whom I have borrowed it actually that time actually, and that is a 76 or 80s paper which talks about the polymorphism and all. There is a Wegener's paper I mentioned, that is a 76 or something like that, or maybe 78, or maybe I do not remember exactly, that is a very famous paper. I do not have the soft copy of that, I will check that. If I get it I will bring it on next time. But those things are, it is not a new thing, this is all old thing, it is nothing, only thing is that the way that they have implemented actually in different languages, as we have seen that in Java there is a different, how the constraints are added, how this, that is a way that differs basically. So all the best. Thank you. Thanks.